Hey there friend, and welcome to this first part on Docker. This is an entire Docker course. It's going to be at least 5 parts. In this first part, you will learn all about what is Docker, what are containers, and how can I create and leverage that in my application development projects. So first off, let's talk about what is Docker. Well, Docker is what is called an open source containerization platform. What does that mean for me? Well, here's the thing. If you're developing applications today, you might have noticed that as you deliver them through various environments such as staging and production and pre-prod or what have you, you need to package your application some way. Now you might zip your application file, you might do some other ceremonies to make that package application end up on prod. But what Docker allows you to do is to package your application into something called a container. And that container, think about it like a black box. That black box contains everything. Your application code, your libraries, your environment files, and you can just take that container and place it anywhere and have it run anywhere. It can run on your host machine, it could run on a server, it could even run on a toaster if it has some kind of Raspberry Pi support, for example. Containers are standardized executable components. And as I said before, everything is in there, right? Your application code, your libraries, and even a hosting layer that enables your container to speak to whatever hosting machine that you're running it on. So is it like a virtual machine? Well, a little bit. It is virtualized, but it's not an entire operating system. So when you have a virtual machine, you're dealing with gigabytes, right? It's a very, very big thing, your virtual machine. But when you're dealing with a container, it's usually somewhere around 10 megabytes to 100 megabytes in size. So it's vastly smaller than that of a virtual machine. But yeah, you can definitely liken it to a virtual machine. So what scenarios should I be using Docker in? Well, here's one scenario. This might not be the most perfect scenario, but it's definitely a valid one. So let's say that you start on a new company, right? You're trying to onboard. You want all of these things installed. A database, maybe an app server, maybe development tools, and so on. All of that, you want to easily install that on your machine. Back in the old days, that could take you days or even weeks to get everything installed. Now, if you use a Docker technology or Docker in the scenario, you can definitely have all of those things installed by just providing a Docker image to that new starter, and they can start installing the tools that they need to work. But probably the best scenario, your environment that you will run your application in will look the same. So regardless whether you get this container to work in development or in staging or in production, it will look the same. So this is more of a joke, right? A developer used to say, hey, this works on my machine, and now that it's no longer running on my machine, it's kind of your problem, because if it doesn't work on staging, there's some ops person that makes this work in staging, makes it work on prod. But here's the thing. If you package your application so that it runs in a container, it will work on your machine, but it will also work on someone else's machine, because you're not really changing, whatever goes into that container. So how does this happen? Well, on a high level, this is where you're starting off, right? You're starting off with. So let's talk about the containerization process, right? So where do I start? I know how to build an app, right? So you build an app, and maybe you want to build a REST API, maybe you want to use Python or Node.js to get there, right? You know how to build an API as a developer. But then, as part of your project, you're going to need to create something called a Dockerfile. This is a text file, and this tells exactly how to create that container and how to put things in it. So here on your right, you can see how we have a Dockerfile, and we have some instructions in that Dockerfile that says, what hosting layer do I want to emulate? What work directory do I want? How do I copy my files into the container? How do I install my libraries? How do I connect whatever port I have on the container towards my host machine? And lastly, how do I start up my application? Once you've done all those parts, you have set yourself up for containerization. Next step is to build something called an image. Now, building an image can be seen as a pre-step to having your application up and running, because at this point you will get something, think of it as a binary almost, right? You've run a Docker build command, you have when you build that Docker image, you do so based on the Dockerfile. The Dockerfile is your recipe. So once you have that image, you just want to turn that image into a container, and you do that with Docker run. So once you run Docker run on that image, you have something that's runnable, something that you can interact with and that your users can interact with. Let's show this in a demo. Let's take you through all of these steps so you understand exactly how you go from 0 to hero with Docker. Okay, so now I've opened up Visual Studio Code. I have built an app. I am using node.js as the runtime, and I'm going to use the Express library to build our API. For the sake of this Docker course, it's fine if you don't understand node.js or Express. The only thing you need to understand at this point is that we are going to build a REST API. It will be accessible at a certain port. So web framework, defining a route, but also defining a port that we should be listening to, and it's dependent upon this variable. Now at this point we have an app. We haven't containerized it yet, so what we need to do is to create a Dockerfile. So create a Dockerfile, and my system immediately recognized this to be of type Docker. You see how the icon changes, but we need some Docker commands. Here we have some Docker commands. So from the top we have from. This is the image or interpretation layer that we're asking for. This is interpretation of a Linux environment with Node.js installed on the system. There are various images for you to pull out there depending on your needs, depending on if you, for example, want a Python pre-installed, or if you want some other kind of runtime, you should be looking for images for that runtime. In this case, we've chosen one for Node. Working directory is something that I set upon the container, so this is where the files will end up. And then I'm looking to copy the files that I need to, so this is copying from and to. So what I'm saying currently is copying all the files into the container at app. And then I'm saying to install the library dependencies if I have any. Then I'm saying to expose a port. This is me opening up a port from the container to my hosting machine. I have yet to connect it to, but at least now it's open from the container side of things. Lastly, I'm adding an entry point, which is a application command to start up the application. So here I'm running the node executable plus the app.js as my entry point. Now what's missing at this point is a package.json. A package.json in Node.js is used as a manifest file, but also keep track of what dependencies I need. I can easily create one by npm init -y. This is a version that's gonna generate a package.json file for me. What's missing here is a script to start things up. Currently, if you look at the Dockerfile, I'm starting it up with Node and app.js, but I could be replacing that with something else in the future. What I am missing though is a dependency. So I need to be installing Express. And now you can see how Express is being added as a dependency. Because we are doing copy everything that we have in this directory, you just want to take this away for the sake of our demo, but you can also find a way to exclude the node modules directory. But for now, we're just going to keep things simple and improve things as we go. Our manifest file in our Node.js project is ready. It says to install Express. And why this is important that this is here is because once in the Dockerfile, when we run npm install, we want to make sure that it's looking into the package.json and know what to install. So yeah, this means that we have set ourselves up to be able to build an image. So our next step would be to call the docker build command with a -t. T is for tagging. This is what a build command can look like. So docker build -t. We can call this anything at this point. Could be calling it docker demo, for example. Let's do that. Let's call it docker demo /node latest. And the dot here is important. What the dot signifies is where to find the Dockerfile. And because this is exactly where we're standing in our app, we can just hit dot. And this means essentially go into the local directory, find the Dockerfile. It is customary to name this Dockerfile, but it could be called other things. We can talk about that in future videos, but you can definitely change from that standard. But at that point, you need to be specific. What is this file called? You can also place your Docker, for example, in a subdirectory, in which point you would have to go to, subdirectory like so. But because we are standing right where we're standing, all the dot signifies is where do I find my Dockerfile. So at this point, we're ready to run our docker build command, and this will build an image for us. Now I want you to keep extra track of what's going on here, and make this a little bit bigger so you see everything that's going on. You see how step 1 out of 6 is executing. This means it's pulling down the image from Docker Hub. Docker Hub is a place on the internet where this image is hosted. You could also host your own place for your Docker images if you are for your Docker images if you're a company, for example. You see how it downloads various parts. This is something it needs to do once, right? Unless it feels like whatever image that you're trying to pull has an update, in which point it's gonna pull down an update to the latest. But there are some things that it needs to do the first time it pulls down a Docker image. You can see that various parts of this is already complete, so we're just waiting for it to finish the last parts. And now once it pulled everything and downloaded everything, it's extracting it. And now you see that it's executing step 2, which is to set a working directory. And you can see it was pretty quick about the other steps. So setting a work directory, copy the files, run npm install, that was also pretty quick. Added 57 packages, and now it's actually created an image. But how do we know? By running Docker images, you can see how we have Docker demo here. So it has created Docker demo, that's good to know. So Docker images is a command that you want to remember because you're gonna run this a lot. And you can also see the size of this. Now, I told you that this didn't need to be this big. And one thing that you can do is definitely to select an image that is way smaller in size. So Alpine is an environment that is way smaller than the node default one. So you can see how the node default one is 1 gigabit, and that's a bit excessive. What we do instead is to build it from a better image that is smaller. And now it needs to pull the Alpine instead, but you will see the great effects of changing from the node default image to that of Alpine, which is a way smaller image. And the other steps, it's done that before, right? So Docker images, and now observe how our size is 179 megabytes. So if you are a node developer, I want you to remember that there's such a thing as Alpine. So what's next? Now, next is that we need to make sure that we can run this application and communicate to it, right? Or communicate with it. So now we can run docker demo/node, so we need to match the name that we have here. And once we do this, you can see how it says example app listening on a port. Yeah, I just discovered my mistake here. You have to use these curly braces for this to work properly. But yeah, we can change that later as we rebuild this image. But the point is, it's up and running, which is good news. But I have actually blocked the access here. So let me show you a command how we don't have to have this to be a blocking thing. Another way to see that this container is actually running is by bringing up another terminal. We can bring up another terminal and we can run docker ps. Now docker ps tells us that we have a running container. This is a command that you definitely need to remember. So docker ps, this will give you all the running containers. It won't give you containers that isn't running anymore, but if they're up and running, you can see that they are created. You can see what status they have, what port that they are available on. Here's a problem though. We have only exposed the port from the container. So 3000 is the internal port of the container, but we haven't actually mapped it to a port on the hosting machine, which makes it impossible for us to actually communicate with it. So what do? So what we can do instead is to run this command. We can run docker run -p, and by adding -p, this is the same thing as specify your ports. And this should be read as 8000 is your hosting machine port, and 3000 is that internal port that we set in the Dockerfile. And then you give it the name of the image. Now we still have that thing with the port that we have fixed in code here, but we have an example app that's now up and running. We should be able to see it. And there we have it. This is actually running from our container. You can see how this one does hello world and localhost 8000. Before this, it didn't work. The reason it didn't work before is because the internal port had nowhere to go, but now we're actually connecting our hosting machines 8000 to the internal port, so it is in a sense port forwarding then to the container. I bet you're wondering at this point what we're going to do about this, because I'm effectively kind of blocking our terminal, right? Well, if I'm starting a new terminal, I can do so. But note how I now have 2 instances of Docker demo up and running. What can I do about that? Well, I can either take the names of these containers or the IDs. So you have container ID or you have name, and by identifying or taking either party, we can stop these containers, right? Because we don't want 2 separate containers running. We actually want 0 containers running because we're about to do some fixes and then some improvements to our image. So we can stop it by, for example, typing 3 characters like so, and this would match here. Or if I wanted to stop this one, I could hit 970. So you always want to find the easiest way to type the smallest amount of characters to stop your container. So now I'm telling my container to go down. So docker stop 992. So wait a little bit, it should stop it shortly. So let's say that actually happened. We can do docker ps, and now we see that that's down, so we can stop the other one. Docker stop 970. Hopefully that goes a bit faster. And now you see how that's also brought down, and docker ps, and we see we have no running containers. So now we've learned how to stop our containers too. And yeah, we've fixed this part in the code. The way for us to pick up on these changes is to rebuild the image. So if you remember our docker ps command, docker demo, so if you remember our docker build command, this will actually rebuild the image, and we will pick up on this thing on line 10. But before we do that, there's another improvement that we want to do. We want to do this little change. This is us creating an environment variable called port, and we're setting it to 3000, and we are trying to expose it like so. And this is great, right? Now we have an environment variable. This is something we could be setting. And this is what we kind of need to do as we move through various environments, moving through dev, moving through staging, moving through prod. Imagine that you need to point to a specific server for different environment or a different API or different set of credentials. Environment variables is your friend here, so this is how you would create an environment variable. We also want to go inside of our app and leverage that environment variable, and in Node.js specifically we go to process environment port to use that. And now that we've done those changes, we can again now do a docker build, and this time it's way faster. It has cached all of those images, and we can see docker images that we have a new image that was created 3 seconds ago. So now we have typed out a docker run command, and this is our usual -p command, right? You've seen that command before, but we're gonna add -d, and d stands for daemon. Daemon means that we're gonna run this in the background. So docker run -d for daemon, and then -p for the port connection, and this will allow our terminal not to block. So you saw before how I circled through various terminal windows to be able to shut down the container. This is a way to have it run in the background. So now we're going to pull up our container by running it, and you see that it responds to me with an image instead of blocking. And this is great. This is how I want to do things. So this is kind of a best practice of how do I start up my container. Right, folks, one last command I want to show you as part of this video, which is docker exec. This enables you to go inside of your environment in an interactive mode. So here I've connected to it. I did docker exec -it and the first few characters of my container ID, and then sh for shell. Now I'm actually inside of the container. I can see exactly what goes on in there, what it has installed for me, or rather copied over. So Dockerfile and app.js package.json was copied in. Node modules and package lock was something that was created as a result of us running npm install. So here you see exactly what this looks like. You can, for example, go and run head Dockerfile if you want, just to see what the Dockerfile looks like. Look at the app.js and so on. But yeah, this is an excellent tool for you to see exactly what files are copied over, if there's any problems, if there's anything that's part of this container that makes it break for whatever reason. Docker exec, this is definitely what you want to be running, and exit to get back to where you were. That was it, folks. You learn how to containerize an application, and you learn concepts such as containers and images, and how to start up a container from an image, how to interact with a container to make sure that everything worked all right, but also how to take it down with Docker stop. So yeah, this first intro was all about Docker. If you like this kind of video, I really appreciate a comment or a like, and even more so a subscribe. So I hope I see you in the next part of this video or another video. Bye for now.